Hey guys, so today we're going to start with a little introduction to organic nomenclature. So we're about to start getting into really naming organic molecules, and today we're going to start with just the basics. So we're going to go from being able to name something like this first molecule, which is just simply methane, to naming the second molecule, which is something like 17-beta hydroxy 8-alpha 4-androsten 3-one, which is more commonly known as testosterone. Okay, so we're going to go from naming something so simple to naming something that's a little bit more complex. So before we start getting into really naming molecules, we need to do a little bit of a review of the periodic table of elements. So if you guys remember, the periodic table, there's your rows and then there's your columns. We call the columns groups. Okay, so if you remember with our groups, think back. This first group is, this is group 1. This is going to be group 2. All the way through here is our transition metals. Sometimes this is referred to as group 3, sometimes it's referred to as 13. Here's group 4, 5, 6, or 16, 17, and 18. Okay, when you look here, and what we're really going to be focusing on with organic compounds is carbon. Okay, that's the biggest thing to remember when we first start out. And carbon, if you guys remember, is right here. It's element 6. Okay, and you can see it's in the 1, 2, all the way through here, 13, 14. It's in the 14th row. Okay, so if it has 6, if it's the 6th element, that means that it has 6 electrons. If you guys remember back to our lesson on electrons, okay, you think back to the orbitals. In the first orbital, the s orbital, it can hold 2 electrons, so that gives us 4 electrons remaining. When we have 4 electrons remaining, they're going to be in the p orbital. Those 4 electrons are then going to be our valence electrons. That means that they're on the outer shells. Okay, carbon here has 4 electrons. It's going to fill each of these different orbitals. When it's filling the different orbitals, these are going to be unpaired electrons. What those unpaired electrons do is then they have to form a bond. When they bond, that means because carbon has 4 unpaired electrons, it can have 4 bonds. Because hydrogen is the first molecule, it has 1 valence electron, it can have 1 bond, because all the bonds want to have a pair, or all the electrons want to be paired up. Okay, so every time we see a carbon when we go to naming our molecules, when we go to naming our organic compounds, they're going to have one single bond, because they have 1 electron, they want that 1 bond to cancel, or to even out the pair, the electron pair. Okay, so if we have 1 carbon, we would have 4 hydrogens. Hydrogen has 1 bond, carbon has 4. It's going to bond, 1 hydrogen is going to bond to that carbon. If you have 2 carbons, the carbons are going to bond together, and then you're going to have 6 hydrogens for the 3 remaining bonds. So you have these 2 have a 1 electron here and here, and then they bond together there, so that gives it its pair. You have a hydrogen molecule, or a hydrogen atom, hydrogen atom, hydrogen atom bonding to the 3 remaining lone pair electrons. Again, here, 3 hydrogens to the lone pair electrons. When we go to draw organic molecules, each peak or end represents a carbon. So here we'll have a carbon. Here we'll have a carbon. Carbon, carbon, carbon. And you don't draw in your hydrogens just for the sake of making the molecules a little bit easier to read. So if we look at this first molecule, you're going to have 1 carbon and 2 carbons. So that means when we go to make the molecular, or the compound, the formula, we're going to have C2H6. That's the one we just saw on the previous page. When you look at the next one, you're going to have 1 carbon, 2 carbon, 3 carbons. So you're going to have C3H8. We can count here if you look, 1, 2, 3 hydrogens if you can imagine it. 1, 2, that'll give us 5, and then 1, 2, 3, that'll give us 8. Looking down at the next one, there's 1, 2, 3, 4 carbons, okay, and then we'll have 10 hydrogens. So if we count them up, there's going to be 3, 2, 2, 3, and that's going to give us 10. When we go to actually naming our molecules, first thing we're going to start out with is we're just going to start out with things called alkanes. Okay, our alkanes are all going to have a prefix or a suffix that is ane. When we get to more complex molecules, you'll see that there's different suffixes for each, for different types of bonds and things like that. So the first thing you're going to do when you go to naming your molecule is you're going to count the number of carbons. Then you're going to want to find the number of hydrogens. If you don't want to count them all, which you should just to make sure, but just if you don't want to count them all, an easy thing to do first is take your number of carbons, multiply it by 2, and then add 2 to that, and that's going to be your number of hydrogens. But even after you do that, just to make sure, I would still self-check, count individually your hydrogens, imagine them on there. And then you're going to use this list, and you're going to use the prefix to name that molecule. So what I want you guys to do now is I want you to take out a piece of paper, and I want you to write down the number of carbons times 2 plus 2 is your number of hydrogens, and I want you to copy down this list. So if there's 1 carbon, it's going to be methane. If there's 2 carbons, you're going to have ethane. 3 carbons, it's propane. 4 carbons is butane. 5 carbons is pentane. 6 carbons is hexane. 7 carbons is heptane. 8 carbons is octane. 9 carbons is nonane. 10 carbons is decane, 11 carbons is indecane, and 12 carbons is dodecane. Okay, so let's look here now. We're going to look at our carbons, and this is going to be your examples, and this is what we're going to look at in class. So here we have one single carbon with the 4 hydrogens. That's going to be, like we said, methane. CH4 methane. Our next one, we have 2 carbons. It's going to be C2H6 ethane. Our next one's going to be C3H8 propane, C4H10 butane, C5H12 propane, C6H14 hexane, C7H16 heptane, C8H18 octane, C9H20 nonane, C10H22 decane. Okay, so now if you're looking at these, I want you to pay special attention to these. We're going to be doing an example, an activity with these different alkanes in class tomorrow. Make sure you copy this list of prefixes down. I'll go back and give you another 30 seconds to get it copied down. Okay, so a big thing with these is you just need to remember what the prefix is. Prefix is big. Okay, it's very important to make sure you copy the prefixes down and get those committed to memory, because once we start to get all the alkanes down, we're going to start to get to a more complex material. We're going to start talking about alkanes and alkenes and alkynes and adding a whole bunch of other information. So it's going to be very important that you remember the different prefixes. So we're going to have to commit these to memory, and we're going to have them. For the first couple weeks or so, you'll be able to use this sheet that you're using now, this little reference sheet. But once we get further into the organic nomenclature, we're going to see what we can do without the prefix reference sheet. Okay, hope you guys got all this copied down, and I will see you in class tomorrow.